Gupta and Sunita Kavani to give us insights about OpenTelemetry and observability essentials. So they both are like founding engineers from Six Scalar, and so I think Sunita comes with 15 plus years of experience, and Sonam started her career, and she's very good at like giving talks and all of that in community activities. So we are happy to have them, present this through our Women in Cloud Native. So yeah, here we go. I think Sunita and Sonam, so you can start giving the presentation.
Thanks, Vani and Nancy, for arranging this. Hello, everyone. I'll just share my screen. I hope my screen is visible.
Yep. Yes.
Yeah. So today, we are going to talk about OpenTelemetry and open source observability. Basically, using OpenTelemetry to add visibility in your application. So agenda for today is we'll go over the introductions and uh, like what is definition of OpenTelemetry, what is OpenTelemetry, and what are the components of OpenTelemetry, and how it plays a part in the distributed tracing. And we also show some examples of instrumenting your application in various languages using OpenTelemetry, and and then live demo on our observability application. So to start with introductions, my name is Sunita Kavani. I have done my bachelor's in computer science, and then I have worked as full stack developer for almost like 15 plus years, and I've joined Sixscaler as a founding engineer, and I'm working remotely out of Pune. Sonam, you want to give your introduction?
Yeah, hello everyone. My name is Sonam Gupta. I am a BTech graduate in Information Technology, currently serving as founding engineer at Siglins. So I am a front-end developer and I work closely with the UI team to build the interface. And I work remotely from my home, from Prayagraj. Thank you.
Thanks, Sonam. Yeah, so let's begin. So what is OpenTelemetry? So little background about OpenTelemetry first. It is a second most active project being worked on in CNCF community. And then it is basically a merger of two prior projects, Open Tracing and Open Census. So both these projects were working parallelly on solving this tracing, uh, like defining standards for implementing tracing in applications. And then they decided to merge in 2019, and then OpenTelemetry came into picture. It is basically a set of standards used for instrumenting any application or system, irrespective of language, infrastructure, or runtime environment. What this means is there is no kind of lock-in, like it is not specific to your programming language or a runtime environment. It is open, and it is compatible with any kind of runtime environment. And So, to get into technical terms, telemetry is basically collecting and transmitting data from remote locations to a monitoring center. And if you translate this into like computer software terminology, it is a system designed to create and manage telemetry data. In software terms, this data can be like logs, metrics, and traces data that comes from your applications. OpenTelemetry, it provides you tools, APIs, and SDKs to collect, create, and manage this data. And how OpenTelemetry is useful? It is useful to analyze your system performance and behavior, like why a particular component of, like why a particular system is slow, or understand the behavior. Then this data can be useful. One thing here to understand is OpenTelemetry is not an observability backend. It will not give you dashboards or creating alerts or visualizations. Um, for that, you will have to use some open source, some observability solutions like Prometheus or Jaeger, or like Siglens for that matter. We are open source and free. Or you can use commercial products like Datadog or Splunk. So, role of OpenTelemetry in observability. What is observability? Observability is the ability to understand the internal state of an application based on based on the data it is producing. So, application is producing logs, metrics, and traces, and using this information, we need to understand what is wrong, what is a problem area in your application. So. So producing this data is called as making the system observable from outside. So for that, when you're writing the code, you need to integrate some libraries inside it, so it can emit these traces, metrics, and logs. So OpenTelemetry provides a mechanism to instrument or add this code in your application code. And once the data is generated, the telemetry data is generated, then we can send it to an observability backend and then visualize that data. So why this is important again, as we know, like with the rise of like cloud computing and microservice architecture, it is getting very hard to debug like what is the problem, where is the problem in this distributed system. So observability helps in that, and then OpenTelemetry helps producing that data. So just to give an overview of OpenTelemetry pipeline. So when we say we are going to install OpenTelemetry, what we get is a we install a Open Otel. Otel is a short form for OpenTelemetry. So when we say we are installing Otel, we basically install a OpenTelemetry client on your system, which is also called as a Otel SDK. And on top of that, we have Otel APIs. Basically, APIs is like a interface, like how to like to access the SDK functionality. We have the APIs on top of SDKs. So when you auto instrument, when you add instrumentation code in your application, uh, it uses these APIs, which in turn uses the SDK functionality, and it generates logs, metrics, and traces data, which you can either send to a third-party service, or you can use something called as Otel collector, which can take this data and it can process this data and export it into now respective observability backends. So for metrics, for example, you can send the process data to time series database, and tracing data can go to trace database, and logs data can go to columns database. So this is the general pipeline of OpenTelemetry. Again, we can go into the details of various components. So starting with software components, as I said, API it defines the basic data types and operations for generating and correlating traces, metrics, and logs data. And SDK defines the requirements for language-specific implementation of these APIs. So SDK has the actual implementation inside it, and once you install, you don't touch the SDK. All you do is you access or you call the APIs. So SDK is untouched. So this gives you a separation of concerns. Like, so even if the backend changes or SDK changes, the APIs remains the same. So so I mean, you don't have to change your code even if the implementation changes. So SDK also has like configuration and data processing uh, concepts defined inside it. So in data processing, you can so it can take any kinds of and exporting it can take any kinds of formats to export the data. So OTLP is basically a Otel protocol. It defines how each data signal should be encoded and transferred across the distributed systems. They have come up with their own protocol for that. Um, there is a concept of sampler. So as you can imagine, when in case of a distributed system with or microservices with multiple microservices running, each operation can generate like a large amount of traces. So sampler is something that helps restrict the amount of traces generated by the system. There are so they come into picture in the processing part of the pipeline. So you can either once you have the traces, you can either do head or tail sampling. Like beforehand, you can decide how much traces, spans or traces you want to ingest, or after collecting the data, you can decide which ones to keep or discard. So that is a tail sampling. And this is important because when you are sending data to observability backend, those systems, they charge based on the ingestion amount of data that is being ingested. So to reduce the ingestion cost, sampling is important. And another component is Kubernetes operator. So it is an implementation of Kubernetes operator that manages collector and auto instrumentation using OpenTelemetry in the Kubernetes environment. So if you want to instrument your Kubernetes cluster, that is also provided by OpenTelemetry. Uh, Collector is an important part of the OpenTelemetry pipeline. It is basically a vendor agnostic tool that can receive, process, and then export the telemetry data. So as you can see, it can receive data in multiple formats, and and then it can send data to more in multiple formats again to more than one backends. So main component for the collector is the processing part of it. Here you can either, like, there is a batch processing. You can either do filtering, batching of the data together, or even you can like do encryption or hide the sensitive data. That kind of filtering also can happen in the processor. So it is recommended. So you can send the data from your system directly to observability backend. That will also work if your observability backend supports this any of these formats. But it is recommended to use Otel collector because so once the system offloads the data to the collector, the system can go back doing its own thing. It doesn't have to worry about batching your data or filtering your data. That thing can be taken care by the collector. So it doesn't add to the latency of your system. So it is recommended to use Otel collector. Now, coming to the concept of distributed tracing. So why this came into picture? Before tracing, people used to have logs in their applications, and logs are basically they give information about the event that happened. There will be timestamp and some text and some information associated with it, but it will not give you information about the transaction that it was part of. The log came from which part of the transaction, which part of the system it came from. Sorry. So that information was missing from the logs. Um, so when people started thinking of tracing allows you to track the journey of request as it moves through different services in a distributed environment. So it provides a way to understand how the information is flowing, through these services, and then it also helps you now debug and understand the issues and errors in the system. So that's how the tracing came into picture, where trace is a map that outlines the path of a request through the system. So it is basically collection of spans or transactions. And span, again, is a single work of unit in the system. Uh, it contains information about specific operations, like when did the operation started, how long it went on, and what are the associate attributes. Like you can add attributes to the span, which you can use downstream to debug or to filter the information. Again, that information can be added as span attributes, which are key value pairs. and they provide additional context or metadata about the span. One important concept for tracing is the context propagation. So if you have a microservice architecture or distributed system, and if you want to send context objects, if you want to send information, suppose I have started one transaction and the data is flowing from one system to the other. I want to send the trace ID or transaction ID to another system, and that gets propagated. So it is called context propagation. Uh,
Sunit,
yeah,
sorry to disturb. I think Jack wants to ask something.
yes.
I've heard about OpenTelemetry, but I'm just now learning about it. So thanks to your presentation. Is OpenTelemetry part of Jaeger? Is OpenTelemetry replacing Jaeger in the context of tracing,
So
or is Jaeger implemented using OpenTelemetry technology?
so Jaeger is something that is ingesting the tracing data that has been generated using OpenTelemetry. So,
Okay, got it. Okay, good.
yeah.
Okay, thank you. Next question. I have lots of customers who are using Splunk. Does OpenTelemetry play nice with Splunk?
Yes, Splunk must be providing you an endpoint where you can send
Yes.
OpenTelemetry data. So, so if you have an application that is generating these traces and spans, then you can send it to Splunk, and it will show you then nicely like how your system is behaving. It will show you the diagrams, and you can query. So as long
Okay.
as the backend is supporting the giving you way to ingest that data, then it should support that.
Okay. Very good. Thank you.
Sounds
Yeah, Sunita, sorry, like there is one other question. We will all like answer the questions at the end. I'm just eh, Yashvi is asking about. Can you repeat why Open Collector is recommended? That's what he's asking. Yeah.
Yeah, so my point about collector was, uh, so if you have a like very time sensitive operation going on in your system, and if you are also emitting traces at the same time, so if you involve collector, then you can just send the data to collector and then go on to doing your operations. And the collector now, if you want to do some filtering, some encryption, that operations can happen in the collector. So your application doesn't have to worry about that. So it doesn't add up to the latency of your application, the overall time it takes.
Sure. I think thank you, Sunita. I think we'll just do the question Q&A in the end. You can now proceed with the presentation. Yeah.
Yeah.
Sorry.
Yeah, so as I was saying, context propagation is an important concept, like how the data gets transferred. So, like if a transaction began in one system and it is, suppose there's an example like online shopping cart example. So the minute I press checkout button till my order is confirmed, that can be one transaction, and then that can have an associated order ID or customer ID. So that information needs to be propagated throughout the various systems that it goes through. So in that case, context propagation is important, and you can send this information. One example is using HTTP headers. So this is an and also like when you're storing this information, so one system has to understand, uh, like all the systems has to agree on the conventions that are used. Like suppose there is a host and we want to say host name is something that I want to store in the span. So all the systems should store it like host.name equal to abc. So the next system, when the span is travel when the request is passing through, the next system will also refer to host name as with host.name and no other attributes. So those are the specifications that are defined in OpenTelemetry. And then this is so since these are the standards, everybody should follows this, and then it helps uh, tracking the same span or trace or span throughout the system. So those are some of the conventions that are followed. So as I was saying, the example about shopping carts, for example. So a trace would represent an entire process a customer's order from the moment like we press a checkout button to the order confirmation, and then we have multiple spans in this. So if you see this diagram, so this is a trace, uh, and front end is a service, and the HTTP post is a trace, and it is comprised of all these spans. So each single operation like placing order, um, prepare order, and shipping code from cart. So each of these operations are different spans in this trace. So get cart, get product. So looking up into the inventory and seeing if the product is available. And so different things like this. So this is just a screenshot. We will show you the actual thing later. But um, just to give an idea that these are the spans. And so what is this? This is the amount of time or the duration from the beginning, how much time this operation is taking. Okay, each operation. So now imagine a big picture, like why this open telemetry plays an important role, why tracing plays an important role is, suppose you have a system and you might think, okay, I want to optimize my system so it takes less time. So you would say that, okay, I'll go and optimize the payment service. But if you, like, for example, suppose that this is a payment service, it is not taking a lot of time, it is quite fast. So when you look at diagrams like waterfall diagrams like this, it helps you understand the problematic service or where you should focus on. Like, for example, you might want to focus on get card service, which is taking more time. So uh, so this is hard. Like, there is no error coming out of the system, it is just the slowness. So it's very hard to debug where is the problem. But when you look at waterfall diagrams like this, it gives you clear idea, okay, this is the latency of this service, and this is where I can optimize or improve my system. So in that case, it is very helpful. If there is a error in any of the spans, as you will see later, then these things will come in red. So that also helps you debug the application. So this was the like overall introduction to the concepts in OpenTelemetry and how it is useful in observability. Now Sonam will take over and she will talk about the instrumentation part of it. Sonam?
Yeah, let me share my screen. Yeah, I hope my screen is visible.
Yes.
Yes.
Yeah. So now Sunita has told you about distributed tracing and open telemetry. Now we will discuss about instrumentation. So instrumentation refers to ensuring that your application codes generate the telemetry data like traces, metrics, or logs. It can be done in two ways: manual instrumentation or automatic instrumentation. Sorry. So manual instrumentation is where the developer takes the charge of creating and managing the span. They decide when the spans should begin or end, or what information to include in that. So manual instrumentation provide a high level of control and flexibility, but it takes a lot of time to implement. While automatic instrumentation or auto instrumentation involves using pre-built libraries or agents that automatically capture and send the telemetry data without requiring you to modify your actual application code. It is typically used to capture the standard metrics like CPU usage, memory usage, error rates. It is less flexible than the manual instrumentation, but it is much simpler and quicker to implement. Now, Now I will show you the demo of how you can auto instrument an application. So let's go to Siglins docs where you will find instrumentation for traces, and we have a detailed overview an examples for setting this instrumentation in different languages. As you can see, we can have applications in Go, Java, Python, or JavaScript. So I will give you an example of Java. So as you can see, there are a few steps just to set up this auto instrumentation. So first, you need to install Siglins, and then in a separate terminal, you can clone this Spring project, the Spring Client repo. Then you can build this package, and then you need to download the OpenTelemetry Java agent. And now you have to start your Java application with this OpenTelemetry Java agent. So I will show you this step because I have already cloned the repo. So as you can see, in one terminal, I am running Siglens locally, and in on other, I will show you the last step to start the JavaScript application with the OpenTelemetry Java agent. So I have started. So I have started the application. Now the next step is to go to this Java application. So this is running on localhost port 8080. So this I am here. So this is running. Now you need to use it a little so that the interaction will generate some traces and will send it to signals. So let's do something. Let's add an owner. So we added an owner. You can add a pet. Yeah. Now if I go to the Siglins, my local Siglins instance, you will see in this, I have the my service that I have sent it from here. So I have the Otel source attribute service name as my service. So I have that here. So now you can see using it a little had made it like more spans. You have added a span for each of the things. So the transaction for selecting anything, you can see there. If you do anything on that application, you will get the traces here on this. Now that's all we have to demonstrate the
So,
yeah.
so can I ask? So, forgive my ignorance here. So, Siglens is Siglens like Splunk? Can I use Siglens instead of Splunk if I'm just doing Kubernetes OpenTelemetry?
Yeah, you can replace your
Ah,
with or Siglens is open source, so you can just replace it with this, and you can play around with all your data here.
do you offer a hosting service like Datadog?
Hosting is currently enterprise service. Since we have open source repo, we are encouraging people to install it in their own environment.
Oh,
And
so you want to self-host it? You don't want to do a Datadog type. Okay, that's fine. That's fine. Okay, thank you. I just didn't know. I learned something. Thank you.
So with this demonstration, you'll get it like how straightforward it is to set up a auto instrumentation for any application or any different language application using Siglins and OpenTelemetry. With these steps, you can like quickly gain the visibility in your application performance. Now, let me switch to the playground instance, Siglins playground instance. So I can explain you more about the tracing UI and how you can visualize and analyze your tracing data. So here you will see a tracing option in the side navbar. You go there and you will see 3 tabs: service hill, search traces, and dependency graph. So on this playground instance, we are using an hot rod application to send the microservices based app. So hot rod application is a sample microservice based application which sends the distributed tracing. So this application generates traces and then we can visualize on Siglins. So The first page is service health. So on this page, you will see all the services in a tabular format. So this page provides you an overview of your application health and performance. It shows you the list of all the services and the red metrics related to it. So this section relies on the rate, error, and the latencies or durations. So let me talk about all these columns. So first one is rate. So rate is the number of requests your application process per second. Now we have error percentage. So error percentage is failing request. The percentage of failing request, that is the ratio of error request to the total request. And all of these are the percentile latencies. So this tells you about the duration of this give you insight about the duration of a services. So if I talk about P50, so this means that this tells you about that 50% of the requests have a response time equals to this or less than this. Similarly, for P90, that means that 90% of the requests have a response time is equals to this or less than this. And for P99, it tells you that 99% of the requests have the response time equals to this or less than this. So red matrix helps you to spot any performance bottleneck or any failure across your system. So if you want to take a deeper look into a service red matrix related to a service, you can just click on it and you will see a detailed graph view of these all the red metrics. So first one is rate per second, and then error percentage, and this is the latency, the application latency graph. So you can here change the time range just to look at different time window and find the data, or so it helps you, like let's say for example, if the error rate of your application or service increases, so you know that at what time the rate is increased or how it is affecting the user experience. Now let's head to the next screen. So the next screen is search traces. So this screen helps you to narrow down your like specific traces you want to analyze. So on the left side, you can see we have a different criterias to filter your traces. So you can filter your traces based on service, operation, tags. So as Sunita said previously, we include some information to a span which remains with it for the lifetime. So these are the informations that we store as tags in a particular span. You can look back for a trace for a particular time window, or you can filter the trace based on the minimum or max duration. Now, if I do a search and I will get a result here in this format. So here you can sort your traces, your result traces as duration. So the longest duration or the shortest duration, or you can have it sorted based on the spans. So let's say I will do more spans. Now this is a bubble chart. So this bubble chart is where the each bubble represents a trace. The position of each bubble is how much duration it takes and what is the start time. So if you see, this is a trace and this is the service name and this is the operation name. This is the duration for the trace, and this is the total number of spans including in this trace, and this is the number of error span. So if you want to get a over like more detailed view of this trace, you can just click on this trace and you will get this Gantt chart view. So on this screen, we will display all the traces, all the spans associated with this trace, and this rate, start time, durations, and all the things. So this is a Gantt chart representation or waterfall representation. This is usually used to see the parent-child relationship. So now you can see here that this is a parent span and these are the child span of it. Now here you can see how much duration each span is taking, and to get more detail of a span, you can either hover over to see like all the detail of that particular span, or you can just click on it and you will get a right box that will show you the details. So this detail includes the operation name, the span ID, the service associated with that, the start time, end time, duration, and the tags. So how these tags are useful, like right now you are seeing HTTP status code 200, but if you get an error code, then you know that this is the service or this is the operation which is causing problem in your application, and you can resolve the underlying problem with this identification. Now you can see that we have this red highlighted span. This is an error span which is highlighted in red color just to know easily that this is the span which is causing some error. Now let's head to make screen. So this screen is dependency graph screen. So these graphs give you an idea of your of all the services in your infrastructure, and it tells you about like how one service calls the another service. If you see the number on the edge, so this number on the edge is how frequently the service is calling this one. So let's say if we have this customer service and this is MySQL service, so how frequently customer is calling MySQL shows this number. So after every 1 hour, we refresh this dependency graph. We can also take a look back to find different time range or dependency graph. We show here at which time this dependency graph was generated. Yeah, so that's all about the Siglins UI for tracing, like how you can visualize the traces that you have sent to Siglins UI. So this provides you a better way to find any potential bottlenecks or any failure in your system, just if you have these three screens. So now we're done with the demo. So these are the resources we have used, like OpenTelemetry docs, Siglins repo, and Siglins docs. So now this is the end of our talk. So thank you everyone. I will now tell you something about Siglins. So Siglins is an open source project. You can on just once install script, you can install Siglins locally, and then we are open source. So you can play around with your data, and we provide all the things like log, metric, traces. You can have alerting on your logs, dashboards, all the things. So you can try us out, and this is our GitHub repo. So if you find any issues or any fixes that needed, so you can file issues, or you can connect with us on Slack community to discuss anything. Thank you, everyone.
Yeah, thank you so much, Sunita and Sonam. Like, yeah, it is like very well explained presentation with a really nice demo. So yeah, I think everyone is in our audience engaged a lot. So if you have any questions, feel free to ask them. So we can use this time to get your questions clarified. Everyone, you can feel free to unmute and ask directly.
Hey, hi everyone. Am I audible?
Yes.
Hi Sunita, hi Sonam. Thanks a lot for that presentation. I really liked it. It was a really nice demo. Bhavani, thanks a lot for organizing this. I have been following you on LinkedIn. You are a great resource, in terms of DevOps. I am also a DevOps engineer at High Radius, and yeah, lately my work's been related to open telemetry and distributed tracing. So this is the perfect time this happened. Okay, I'll get on with the question. The thing is, instrumentation is one of the thing that we explored, but with the service mesh coming into the picture, like Istio, and recently Celium being a CNCF graduated project, moving into service mesh with its full throttle on eBPF, you know, that I think is the game changer, and it will remove the instrumentation totally, which is partly done by Istio as of now. So our current architecture involves Istio to emit these traces, put it in a vendor, and then we can look into that. But the downside is that uh, it adds latency, which in our case is not very suitable. So it's a trade-off kind of thing. So this question is for the whole forum. Do you think we can use Celium service mesh, because at the end Istio and Celium both are using envoys to actually um, pull out these L7 flows and then get it into a collector and then push it, you know. What do you think exactly? Are we there yet, or is it just an early phase? That is my question.
Yeah, thanks for the question. I am not entirely familiar with all the terms that you used, but I would say that if the technology is new, then definitely it's going to take some time to settle down. And it also depends on your application, and then the trade-off that you want to make. If the latency is important factor, then yeah, definitely go with whatever saves, like whatever takes less time. But yeah, I mean, in my opinion, it totally depends. So in our case, the people are going to use our product to do fast search and fast lookups. So we don't want the latency in our product. So again, I'll say the trade-off, you have to decide. And then with any new technology, it takes time to settle down. So that's my opinion.
Okay, got it, got it. Okay, so that comes down to my second question. So now, since we don't have that kind of tech as of now, uh, do you think instrumentation is a bit more invasive form of way to get these telemetry data? Because with every API call, it is trying to execute maybe little, but some business logic, which is actually giving us spans. So, how do you Do you think uh, it will affect the overall picture, for if I want to prioritize my latency thing?
Yeah. Again, I would say that like if you have a system like made up of different parts, then you would want to identify which is the most important part, where the latency is most, like reducing the latency is more important, and only introduce traces in that part. Uh, I understand, and I completely agree that it is invasive process, but then again, you don't want to know uh, or emit traces everywhere. So as I said, the sampling is also part of that. Like you don't want to generate enormous amount of data and not use it sensibly. So only the like your sensitive or like critical part of your application you would want to, which you are in, like you are thinking in future I might be need to debug that. So that's where you should put it, and I think it will be worth the effort, like reduce the headache later on. is my opinion.
Okay, got it. So we should prioritize whatever we want is critical to our debugging issues, and then instrument those things. Is that what you're saying?
Yeah, that's basically what I'm saying. Yes.
Okay, okay. So if you don't mind, can you give me some implementation examples or some kind of documentation which says that we can limit our um, the actual things that we want to instrument, not just the whole application.
So, as you said, like in my understanding, I'm saying like when you instrument and when you add the call, so you start a trace at some point, and you then you keep adding on to that different spans after a critical piece or after a function call. I think that is what I am thinking, that if you reduce the number of calls to the API, which will create a span for that particular operation, that should reduce. But I might be wrong. I mean, maybe I can look up and connect with you later.
Yeah, okay. Yeah, that will be awesome. I think since Siglins being in this domain, there is a way actually to get these distributed tracing without any instrumentation. I think that's where everyone will go. So I'll definitely like to connect with you, and then based on your availability, that let's discuss.
Yes, thank you. Sure.
Thank you. Thank you so much, Sai.
Thanks a lot.
Yeah. Any other questions? Okay. Yeah, Sunita, I have one question, not with respect to observability, and so just wanted to know the journey of Siglens, and so how you started with Siglens, some of your experience, joining in a kind of a startup as a founding engineer, and probably some kind of suggestions that you give to other women out there too. I mean, I know you come with a lot of experience, so I mean, like, I feel like getting suggestions from you will help us a lot.
Yeah, definitely. I mean, to uh, to begin with, Siglens, our CEO, the founder and CEO, he was working with Salesforce, and and they were using Splunk and other expensive tools for their observability needs. And he knew the core problem that needed to be solved, and he had some ideas, so he decided to implement them himself. So that's how he started the company. I was first to join, and he has been always encouraging women to join the team, and like, uh, and then the thought of making Siglines open source came later on, because we wanted people to use the technology. It is a very powerful backend. The UI, we are working very hard to make it equal to the commercial products out there, but the backend is very powerful, so we wanted people to understand the power of it. So that's why we made it open source, and we are finding like many people are putting it in the production. So yeah, so I started, and then Sonam joined as a part of UI team, and for whoever wants to apply, so since we are an open source repo, the way we are encouraging people is there are open issues on our repo, and you can go through the issues. There are some beginner issues that you can pick up, and then based on the quality of work that you submit, the PRs that you raise, we assess, and then we can consider that is considered as your application, job application. So that also like gets you some GitHub understanding and some contribution that that can show up on your GitHub profile that you have contributed to open source repo, and that also gets you noticed. Yeah, and then we can think of that is the way we are doing the hiring these days, or like we are also taking a lot of interns, and again we give preference to women who are interested in learning more about the technology. So now, do you have any other experience?
Yeah, so I've been working here for 1 year. So after just graduation, I joined Siglins. So I have learned so many things just in 1 year. So I've been working with the front end team, building the whole UI, designing the whole UI, and then building whole the things, working with the interns and other team. And it's been great working here.
Nice. So you also started as like contributing the open source siglins. I mean,
No,
I
so
feel this is unique, Sunita, because like we always, for any jobs, like you see, start off with interviews, but now it's more of like open source contribution to the siglins, knowing more about the product, and then, getting into the team is very helpful for you as a company and as well as the individuals that started after learning, about your product.
Yeah, the thing with startup is they want you to be ready the next day, 100% productive. So it helps if you have gone through the repo and understood on your own, then it helps to catch up quickly.
Yeah, nice. Yeah, I mean, like it's great to have a discussion with both of you and sharing your knowledge on open telemetry and showing us through the siglins is kind of amazing demo. So I know like audience asked a lot of questions, and thank you so much for answering all of them. And Nancy, you have anything to add?
No, Bhavani, thank you so much for joining, and thank you so much, Sunita, for sharing your journey. I'm pretty sure it must be amazing journey for Sonam as well. Yeah, thank you. Thank you everyone for joining us today.
Yeah, thank you everyone. Yeah, keep following Women in Cloud Native and encourage more people into the Cloud Native community. Thank you so much.
Thank you. Bye.
thank you.
Thank you. Bye.
Bye. Thank you.
Bye.